So again, our research is focused on allowing electric vehicles to recharge their batteries on acceleration, during coasting, and during braking. So currently, an EV can only recharge its batteries while it's driving in regenerative braking mode, and that slows down the car. So what we wanted to do when we started this investigation several years ago, we wanted to reduce the resistance produced by the generator by 10%. We discovered that we could actually reverse it, and that's what I'm going to show you with the first prototype. So we have a regenerative acceleration coil over here if you want to come in and have a look here. So this is our regenerative acceleration coil, and this is our rotating magnetic field. Okay, so what I'm going to do is bring the system up to speed, and I'm going to put the system into regenerative acceleration mode, and what we're going to do is we're going to recharge the batteries, and the system is not going to decelerate. So I'll get you to come over here again. And what I'm going to be showing you in the demo what I'm going to show you first is the regenerative acceleration generator, then the regenerative acceleration motor, and this is another regenerative acceleration generator, and I'm going to show you where the regenerative acceleration comes from. And the output from the generator is going to go to these batteries, and we're going to basically witness EV regenerative acceleration. So I'm going to let it come up to speed. regenerative acceleration motor. And the ReGenX coil, the regenerative acceleration coil, when it's incorporated into a motor, allows for the motor to recharge the batteries while in motor mode. So we're basically, with the ReGenX system, we are continually recharging the electric vehicle's batteries. So now what I'm going to do is I'm going to basically run the ReGenX coil that's in this prototype as a motor coil, and we will show you regenerative acceleration with the motor coil. Because the regenerative acceleration coil creates complementary electromotive torque rather than counter torque, it can be integrated into a motor coil and recharge the batteries while in pure motor mode without any deceleration of the system. Right now we're putting in about 1.5 amps into the motor coil, and we're collecting back a little over an amp. And we are recharging the batteries in pure motor mode. Again, the nature of the regenerative acceleration technology is to allow electric vehicles to recharge their batteries on acceleration during coasting when the motor coil goes into generator mode and on regenerative braking. Are you familiar with sine waves, current sine waves, voltage sine waves, that sort of thing?
Sine waves?
Sine waves, yeah, like on an oscilloscope.
I think
Okay.
I understand.
Okay.
Yeah.
So the difference between a regenerative acceleration coil and a conventional generator coil is the regenerative acceleration coil has between a 45 and 70 degree load current delay. And what that means is the sine wave, the current sine wave for the regenerative acceleration coil is delayed in the time domain. So what I'm going to show you with this prototype has two coils in it. It has a conventional coil that's connected to this light bulb, and this is the conventional coil. When it's placed on load, the system will decelerate as per conventional regenerative braking. And when the yellow coil is placed on this load, we will see acceleration of the system, but this load and this load, or this load current and this load current will be observable on the oscilloscope. So what you're going to see is you're going to see, and this is just the top half of the sine wave, you're going to see, this is the conventional coil's load current sine wave, the top half. And in a conventional generator, basically this is a magnet that's approaching a coil. And as it gets closer to the coil, the current builds in the coil. And the resistance that we felt in the conventional generator, the resistance, the magnetic field produced by the coil is resisting the magnet's approach, and then when the rotor magnet is basically top dead center to the coil, when it starts to move away from the coil, the current flowing in the coil changes direction, and the north pole that's produced by the coil, which is causing the resistance, is now a south pole. So in a conventional coil, you have a north pole magnet approaching a coil, and the coil is inducing a north pole magnetic field resisting the magnet's approach. When the magnet moves away from the coil, now the current has changed direction, and the coil is inducing a south pole, which is resisting the coil's departure from the coil, the magnet's departure from the coil. Because the ReGenX generator coil has a load current delay, the coil produces resistance up to this point, and you're going to see that on the oscilloscope, but from the midpoint it produces assistance from here, because the ReGenX coil is still producing a north pole repelling magnetic field, but the north pole magnet has already passed the coil at top dead center, and now the ReGenX coil is assisting its departure. So it's the load current delay reverses basically the generator armature reaction, or the regenerative braking component. And I'm going to basically show you those two sine waves on the oscilloscope. So now I'm going to put the conventional coil on load. This is the conventional coil's load current. And now I'm going to put the regenerative acceleration coil. You can hear it decelerating. So the middle line here represents the magnet, the rotor magnet, when it's right at the coil. and the so this is the rotor magnet, basically right at top dead center, and from this point onward, the ReGenX coil is accelerating the system. So I'll take the ReGenX coil off here. Now we're basically in regenerative braking mode, and the generator coil is decelerating the rotor. And now we're in regenerative acceleration coil, and again you can see the noticeable delay in the yellow current. The yellow sine wave is the conventional coil load current, and the blue sine wave is the ReGenX coil load current. And it's the load current delay that's created in the regenerative acceleration coil that allows it to reverse the EV regenerative braking paradigm. Okay. So I'm going to go back to this prototype again. And I'm going to show it to you operating at about 1600 RPM. And 1600 RPM for this prototype, for that coil that's in that prototype, is below what we call the critical minimum frequency. And the ReGenX coil, the thing that makes the regenerative acceleration coil work is frequency. Okay, it's frequency dependent. So what that means is the factors that dictate regenerative acceleration are the primary one is coil impedance, and coil impedance is a mathematical formula, and it is inductive reactance plus the DC resistance of the coil. And the only thing that changes in the equation here when we accelerate the system is the frequency. And as the frequency increases, the inductive reactance of the coil increases. As the inductive reactance increases, the coil's ability to conduct current decreases. And it's the current that flows in the conventional generator that creates the magnetic field, which is responsible for regenerative braking. And the ReGenX coil, because of its load current delay, it reverses the regenerative braking paradigm. In order to do that, the ReGenX coil has to be operating above the critical minimum frequency, and I'm going to show you the ReGenX coil operating below the critical minimum frequency. And when it's operating below the critical minimum frequency, it's operating as a conventional coil. Actually, I'm just going to have to do these wires here. conventional regenerative braking, decelerating pretty rapidly. I'll take it up above its critical minimum operating speed.